Today's video we will see the design of 4 to 2 line priority encoder. Encoder, as we know, is a circuit which performs the reverse operation of decoder. Also, it is a circuit which encodes the information from 2 raised to the power input lines to n output lines. Suppose we have 4 inputs, so 4 can be written as 2 raised to the power 2. So it will have, in that case, it will have 2 output lines. Okay, suppose we have 8 output lines, 8 input lines. Okay, 8 input lines. So 8 can be written as 2 raised to the power 3. So this kind of encoder will have 3 output lines. Okay, now how encoder works? So I am just giving you an overview of working of simple encoder. Thereafter we will see the working of priority encoder. Okay, so suppose we have 4 to 2 line encoder. So in that case, this encoder will have 4 inputs. Okay, 4 inputs: I0, I1, I2 and I3. These will be 4 inputs, and there will be 2 output lines. X0 and X1 will be 2 output lines. Okay, now when the value of I0 is high, and remaining input lines are 0, in that case the output generated will be 0 0. Why the output will be 0 0? Because binary equivalent of 0 is 0 0. When I1 is high and remaining input lines are 0, the output generated will be 0 1. Okay, when I2 is high, output generated will be 1 0. When I3 is high, output will be 1 1. So we can say that this encoder is encoding the information from these input lines to output lines. This is the truth table of simple 4 to 2 line encoder. Simple 4 to 2 line encoder means this is not the truth table of priority encoder. First of all, we will understand this truth table. Thereafter, we will convert this truth table to priority encoder truth table. So these are 4 inputs: I3, I2, I1, I0 are 4 inputs, and X1 and X0 are 2 outputs. Okay, when I0 is high, output is 0 0. When I1 is high, output is 0 1. When I2 is high, output is 1 0. When I3 is high, output is 1. When all of the input lines have value 0, this condition is represented by cross, that is don't care. We can say that in that case encoder is disabled. Okay, so this is the truth table of simple encode. Now what will be the output when at a time more than input lines have a value 1? Suppose at a time we have I3 and I2 have value 1 1, both have value 1. In that case, what should be the output? The output should be 1 0, that is the output corresponding to this, or the output should be 1 1, that is the output corresponding to this input line. So now comes the role of priority encoder. Now comes the need of priority encoder. So at a time when value of more than one input lines is 1, the output is decided on the basis of priority of input lines. The output will be decided on the basis of priority. Okay, here we assume that greater number has higher priority, bigger number has higher priority. So suppose we have 3 persons standing in a queue. P1, P2 and P3 are 3 persons standing in some queue. Okay, and these 3 persons have age 50, 65 and 70. So we should serve the person with greater age. We should serve the elder person first. So according to this, P3 will be served first. Why? Because the age of P3 is 70, which is more than the age of P1 and P2. Similar concept we will use in priority encoder. Now according to this concept, when more than one input lines have value 1, in that case output will be decided according to priority. Suppose I2 and I1 both have value 1, in that case output will be 1 0. Because I2 has more priority than I1, because 2 is greater than 1. Similarly, when I3 is also equals to 1 along with these inputs, in that case output will be 1 1, because I3 has more priority than I2 and I1. Okay, so following this concept, we should design a new truth table. Now suppose I0 is 1 and remaining inputs are 0. I0 has value 1 and I3, I2, I1 have value 0. In that case output will be 0 0. But when I1 is equals to 1, then whatever may be the value of I0, whether I0 is 0 or I0 is 1, output output will be 0, 1. So whatever may be the value of I0, therefore I am writing here cross, that is don't care. That is we don't care whatever is the value of I0, it is 0 or 1, the output will be 0, 1. Okay, but for that case I2 and I3 must be 0. But when I2 has value 1, then whatever may be the value of I1 and I0, whatever may be the value of I1 and I0, so cross, 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 this X denotes don't care. We don't care whatever may be the value of I1 or I0. But when I2 is high, output will be 1, 0. Okay, but in that case I3 should be 0. But when I3 is 1, I3 has value high, I3 has value 1. In that case, whatever may be the value of these lower lines, whatever may be the value of these I2, I1 and I0, whatever may be the value of these, we don't care, output will be 1, 1. Now the question arises, what is the difference between these two truth tables? See here this is 0, here I0, in this second row I0 must be 0 for the output 0, 1. But here we are saying whatever may be the value of I0, when I1 is high, we will get output 0, 1. Okay, so this cross says whether I0 is 0 or 1, the output will be 0, 1 when I1 is high and remaining inputs are high, remaining inputs are 0. Okay, when I2 is 1, then whatever may be the value of these I1 and I0, these input lines, whether it is 0, 1, whether it is 1, 0, whether it is 1, 1, output is going to be 1, 0 when I2 has value 1. Okay, when I3 is high, then whatever may be the value of I2, I1 and I0, whether all of these input lines have value 1, 1, 1, but output will be 1, 1 because I3 has greater priority than these lower input lines. Okay, now this is the final truth table corresponding to 4 to 2 line priority encoder. These are 4 inputs, I3, I2, I1 and I0, and these are 2 output lines, X1. These are 2 outputs, X1 and X0. Now for drawing the circuit, we need an expression for these 2 outputs. We need an expression for these 2 outputs, X1 and X0, and for obtaining the expression we need K-maps. Now this is the K-map for X1 and this is the K-map for X0. Now filling these K-maps is quite interesting. Let us start with X1. For value 0, 0, 0, 0, that is I3, I2, I1, I0, when have value 0, 0, 0, 0. This is represented by a cross. Okay, so I should write here a cross. Okay, when value of I3, I2, I1, I0 is 0, 0, 0, 1, 0, 0, 0, 1, X1 is 0. So therefore we should write a 0 here. Okay, when value of I3, I2, I1 and I0 is 0, 0, 1 cross, 0, 0, 1 cross, that is 0, 0, 1 cross can be written as 0, 0, 1, 0 or 0, 0, 1, 1. Okay, because here we are saying whatever may be the value of I0. So I0 can be 0 and I0 can be 1. So in these two cases, X1 is 0. So 0, 0, 1, 0 will also be represented by 0 and 0, 0, 1, 1 will also be 0. Means at these values X1 is 0. Okay, when I3, I2, I1, I0 is 0, 1 cross cross, that is when value of I3 and I2 is 0, 1 and value of I1 and I0 can be 0, 0, it can be 0, 1, it can be 1, 0, it can be 1, 1. So this is the row corresponding to these inputs. Okay, sorry, these inputs 0, 1 cross cross, 0, 1 cross cross means whatever may be the value of I1 and I0. So at this combination X1 is 1. So I should write a 1 in this complete row. Okay, when I3 is 1, then whatever may be the value of I2, I1 and I0, X1 will be high. Whatever may be the value of these 3 inputs, I3 should be 1, but whatever may be the value of I2, I1 and I0, it can be 0, 0, 0, it can be 0, 0, 1, it can be 0, 1, 0, it can be 0, 1, 1, it can be 1, 0, 0, it can be 1, 0, 1, it can be 1, 1, 0, it can be 1, 1, 1. But I3 should be 1. I3 should be 1. At these values, X1 should be 1. Therefore, when value of I3 is 1, when I3 I3 is 1 and whatever may be the value of I2, I1 and I0, for these two rows we should write 1. Okay, we should write 1 because at this combination when I3 is 1 and I2, I1 and I0 may be whatever, x1 is high, x1 is 1. Okay, so this is the K map, this is the filled K map corresponding to x1. Now we come to x0. At 0 0 0 0 we are getting a cross. Okay, at 0 0 0 1 we are getting x0 as 0. At 0 0 1 cross, that is when I3 is 0, I2 is 0, I1 is 1, but I0 is 0 or 1, that is 0 0 1 0 or 0 0 1 1, whatever may be the value of I0. When I3, I2 and I1 have these values, we are getting x0 as 1. So at these two values, x0 is equals to 1, x0 is 1. So at 0 0 1 0 and at 0 0 1 1, x0 is going to be 1. Okay, so x0 is going to be 1 in these two cases. Okay, when I3 is 0, I2 is 1 and whatever may be the value of I1 and I0, x0 is 0. When I3 is 0 and I2 is 1 and whatever may be the value of I1 and I0, whether it is 0 0, it is 0 1, 1 1 or 1 0, x0 will be 0. So this whole row will be marked as 0 0 0. Okay, when I3 is 1, when I3 is 1, I3 is 1 in these two rows and whatever may be the value of I2, I1 and I0, x0 will be 1. So both of these rows will be marked with 1. Okay, so this is the desired K map. These are the K maps. Now we should simplify these K maps for obtaining the final. Now in this K map, that is in K map for x1, we can make a group of these 8s and we can make a group of these 8s. So there are two groups in x1, this K map. Okay, in this K map we can make a group of these 8s. Okay, and now these two ones can be rolled with these two ones for the purpose of making a bigger group. Okay, now we should write the expressions corresponding to these groups. For x1, first group is this, okay, which falls under these two rows, and in these two rows value of I3 is changing, which is 0 and 1. Okay, and value of I2 is fixed, which is 1. So we should write I2 here for x1. We should write I2 for this group. Okay, and in this group falls under these four columns, and these four columns value of I1 as well as I0 is changing. Now in this group value of I3 is fixed, which is 1. So I should write I3 here, but value of I2 is changing. It is 1 here and it is 0 here. So we should simply eliminate I2, and in these four columns I1 as well as I0 is also changing. So we should eliminate I1 and I0 also. Now coming to this group, this K map for x0. In this group value of I3 is fixed, which is 1. So we should simply write I3, and in these columns value of I1 and I0 are changing, so we should eliminate these. Okay, now in this group value of I3 is changing but value of I2 is fixed, which is 0. So we should write complement of I2. Also this group falls in these two columns, and in these two columns value of I1 is fixed, which is 1. So we should write I1, but value of I0 is changing, so we should simply eliminate this. So these are the final expressions for output. Now we should draw the circuit diagram. Now this is the desired circuit diagram. X1 is equals to I2 or I3. So X1 is equals to I2 or I3. Okay, X0 is equals to I3 or I2 complement and I1. So I2 complement is ended with I1, and both of these are connected with the help of OR gate. So this is the final circuit diagram.